Okay, this is kind of part 2 of the beginning of chapter 8 in geometry. So we are still talking about simplifying radicals, but now we're going to throw it into right triangles. So let me remind you of something called the Pythagorean Theorem. So somewhere off to the side of your paper maybe, let's review what the Pythagorean Theorem is. It is a squared plus b squared equals c squared. Okay, important things to review to remember. This only is in special cases of right triangles only. All right, the other thing is the A and the B are the two legs. This could be A and this could be B, or this could be A and this could be B. The order of A and B don't matter as long as they are the two legs which make up the right angle. Okay, the longest side has to be the C, has to be. And the C side is called the hypotenuse. Hypotenuse. Okay, I ran out of room, but that's okay. And the A and the B are the legs. And this could be A or B, and this could be A or B. So, A, B, C, you can always find the length of either A or B or C if you have two of the others, and you use this Pythagorean theorem. Okay, so we're going to use this today to find some missing side lengths. So let's go back now that you've had that quick review and look at number 1. The long hypotenuse side has to be C. But again, this could be A, this could be B, or this could be B, this could be A. It doesn't matter. So I'm going to say 12 squared plus x squared equals 13 squared. And again, these two don't matter because when you're adding, this plus this is the same as vice versa. But the 13 squared has to be the hypotenuse. It has to be what it is equal to. All right, and now we're just going to solve it. 12 squared is 144. 13 squared is 169. We are going to subtract 144 from each side. X squared equals, I don't know, 25. And lucky for us, that comes out evenly because if you square root each side, the square root of 25 comes out evenly as 5. All right, let's try number 2. This time, we don't know the hypotenuse. We just know the two legs. So we're going to say 4 squared plus 3 squared equals we don't know squared. Oh, and I saw they want it to be x. Oops, I put c. Doesn't really matter. 16 plus 9 equals c squared. 16 plus 9 is 25 once again. So that means when you square root each side, c, which is really supposed to be x, sorry about that, is 5 again. Okay, then we get into some decimals, which decimals are still going to be equally easy because you're going to use your calculator, but they're not going to be as easy to calculate in our head. So what I see is we have a leg, and we're missing the other leg, but what we have is the hypotenuse. So I'm going to put 11.9 squared plus we don't know squared for the other leg, but it's going to equal the hypotenuse, which is 14.7 squared. All right, and I'm just going to use my calculator and start solving. So 11.9 squared is 141.61. Plus your x squared equals 14.7 squared, which is 216.09. 216.09, okay? So I'm going to subtract this from both sides. If I'm going way too fast, you can definitely push pause. I just know that this is kind of a review, so I'm going a little bit faster than I normally would if you were learning this for the first time. And I got 74.48. So 74.48, we're going to square root both sides. And here's what I noticed. I noticed in the instructions it says round your answers to the nearest tenth. So I'm going to put this in my calculator, but I'm guessing it's not going to come out nice and neat. Let's see what we get. Square root of 74.48. Yeah, that's really irrational. So nearest tenth would be one place after the decimal. The 3 does not bump it up. It leaves it alone. So 8.6 is what I want to write. I'm also going to do a little squiggly equals, and that means I'm rounding it. It's about 8.6, not exactly, but close. Okay, and then let's try this last one of the top section. And this time it gives us the hypotenuse, which is actually, yeah, it's exactly like number 3. So that's all right, we're going to do it the same way. So 6.3 squared plus we don't know squared equals 15.4 squared. So 6.3 squared is 39.69 plus I don't know squared equals 15.4 squared, which is 237.16. 237.16. So I'm just going to subtract this from both sides. 237.16 minus 39.69 is 197.47. 197.47. I'm going to square root both sides to get x by itself. 197.47. I'm guessing it's going to be yucky again. Yeah, it is irrational again. So this is 14.0, but the 5 does bump the 0 up to a 1. So about 14.1. And again, it's not exact, so I'm going to do about 14.1. Okay, the thing that's different in the bottom section is this time, instead of rounding, it actually wants us to leave our answers in simplest radical form. So that is why we did the pre-lesson, the part 1, because now you're going to need it to remember how to do it for these right triangles for the Pythagorean Theorem part. Okay, 15 is our C, which is our hypotenuse, so 13 and x are the legs. So I'm going to do 13 squared plus x squared equals 15 squared. 13 squared is 169. 15 squared is 225. I didn't use my calculator. I'm thinking this is right. You might want to double check me. X squared equals whatever 225 minus 169 is, which is 56. Okay, here's where we need to talk about how to simplify radicals. For it to be the square root of 56, I need to think of 2 numbers at least, because we might have to break it down again, but we might get it right on the first time. What times what equals 56, and one of them at least has to be a perfect square. Right off the bat, I'm going to try 4, just because I could try, I don't know. I could try something else, but I just feel like I'm going to try, maybe 4 does work, 4 and 14. And I can't think of any perfect square in 14 because the only factors of 14 are 1 and 14 and 2 and 7. And none of those are perfect squares. So that means we are done. So 4 and 14. And when it's 4 times 14, the square root of 4 comes out as a 2 because the square root of 4 is 2. So our final simplified radical answer would be 2 root 14. All right, let's try this one. This one is the same in that we have the hypotenuse, but we are missing a leg. So you're still going to set it up the same way. So 8 squared plus x squared equals 16 squared. So 8 squared is 64. 16 squared is, I don't know past 12 or 13. 256. So 256, we're going to subtract 64 from both sides. 256 minus 64 is 192. And we get to find the simplest radical form of 192. Ugh. So what 2 things can we multiply to get 192? I'll try 64. Yes, I got very lucky here. 64 and 3. You may have to play around with numbers until you find a perfect square that works, but I know that the square root of 64 is 8. So 8's going to come out, 3's going to stay in, 8 root 3. All right, let's do 2 more just to make sure you guys got this. So basically we're given the A, which is one of the legs, and the C, which is the hypotenuse. And they want us to once again keep our answer in simplest radical form. So it is going to be 11 squared plus, I don't know what b is squared. Actually, I probably should have left it b, but that's okay. Doesn't matter. Equals 15 squared. So let's just solve this. That's 121. 15 squared, I think, is 225. Subtract 121 from both sides. X squared equals, what is that, 104? So 104's simplest radical form. Okay. 104 equals what times what? So I probably will not get as lucky this time because I cannot think of anything, so I'm going to start small. I'm going to start with just 4. Okay, 26, the only factors of 26 besides 1 and 26 are 2 and 13, and neither of those are perfect squares, so this is it, 4 and 26. So 4 times 26, and 4 is a perfect square that comes out as a 2. The square root of 4 is 2. So 2 root 26 is that answer. All right, don't let this one scare you because it's already got a radical in it. Let's write it down, and I think this one actually might be easier than you think. So we're missing an a, which is a leg. So we're missing a, so a squared plus root 6 squared equals 4 squared, because that's the c. All right, this is actually easier because if you have a square root and squared, if you're taking 6 and you're square rooting it and squaring it, those are opposite operations. Those are inverse operations. So those actually just cancel out and they leave just 6 by itself. So I love it when you have a perfect square, a square root that you're squaring, because they're just going to cancel each other out and you're not going to be left with having to do any work. So I'm going to subtract 6 from both sides. A squared equals 10. So we get to find the simplest radical form of 10, and I can't think of anything. The only numbers smaller than 10 that are perfect squares are 4, which doesn't divide by 10, and 9, which also doesn't divide by 10. So our actual simplified radical answer is just staying exactly in its form square root of 10. Okay, so we are ready for the next section.